Hello, dear students. I welcome you all on behalf of Shri Jayendra Rank Zone classes. So far, in our series of lectures on ray optics and optical instruments, we have seen some topics based on reflection, refraction, the prism, dispersion by prism, lens, mirrors, optical instruments such as telescope, different types of microscopes, etc. Now let us solve some questions based on these concepts which were asked previously in NEET and JEE examinations. So let us begin. The first question is that according to Rayleigh scattering law, which one is correct? First option states that small size dust particles scatter perfectly smaller wavelength of light. According to Rayleigh scattering, if size of particle is very less than lambda, then they will perfectly scatter the light. So first option is correct. The second question states that a telescope using an eyepiece of focal length 3 cm has magnitude 10 in normal adjustment. If the telescope is now used to view an object placed at distance 180 cm from the objective, the new length of telescope is. Here, eyepiece is of focal length 3 cm. Has in magnitude of 10 in normal adjustment. The telescope is now used to view object placed at distance of 180 centimeters. L is given by V naught plus Fe. And using length formula, we can write 1 by V naught plus 1 by 180 object distance, that is negative, is equal to 1 by 30. Solving this, we will get V naught is equal to 36 centimeter. So first option is correct. Next question. The object and the image are at distance of 9 centimeter and 16 centimeter respectively from the force and equiconvex lens of radius of material of the lens is. According to the equation of focal length, F can be written as under root x1 x2. This is the displacement method. That is equal to under root 9 into 16. X1 is 9 and x2 is 16. So focal length is 12 centimeter. Now applying lens maker's formula, we have 1 by F is equals to n minus 1 into, for equiconvex it will be 2 by R. So 1 by 12 is equals to n minus 1 into 2 by 12. So we will get solving this 1.5. The second option is correct. The next question is, if F is focal length of lens in Ramstein's eyepiece, cross wires are placed at which position? Cross wires are arranged at distance, should be arranged at distance f by 4 in front of lens in Ramstein's eyepiece construction. So correct option is f by 4. Next question. Image of an object at infinity is formed by a convex lens of focal length 30 centimeter such that the size of image is 2 centimeter. If a concave lens of focal length 20 centimeter is placed in between the convex lens and the image at distance 26 centimeter from the convex lens, what is the size of new image? Here, for convex lens, focal length is 30 centimeter and image distance is also 30 centimeter. For concave lens, the object distance is given -4 centimeter and focal length is given -20 centimeter. We can use lens formula. 1 by f is equals to 1 by v minus 1 by u. So 1 by v plus 1 by 4 will be equal to minus of 1 by 20 for concave. From this we will get v is equals to 5 centimeters. Now the magnifying power m is equals to image distance upon object distance. That is equal to h dash by h. So 5 by 4 is equal to image distance by 2. So I is equal to 5 by 2, that is 2.5 centimeter. Let us see the next question. A water film is formed on a glass block. A light ray is incident on water film from air at angle 60 degree with normal. The angle of incidence on glass slab is. Light is incident on water film from air at angle 60 degree with normal. This is the situation. This is glass slab over which there is a layer of water. Light is incident at an angle of 60 degree on air-water interface. We want to find the angle of incidence on glass slab. First, let us find the angle of refraction at air-water interface. We can apply Snell's law. Sine 60 degree is equals to refractive index of water into sine r. Sine 60 is √3 by 2 and refractive index of water is given 4 by 3. So sine r is equal to 3√3 divided by 8. So r is sine inverse of 3√3 divided by 8. This is angle of refraction. Same angle will be made with normal at glass. So first option is correct. Next question. A thin biconvex lens of focal length 20 centimeter is made of glass of refractive index 1.5. When it is dipped in a liquid of refractive index 9 by 8, it will act as. Here, the medium is changed. So, to check the effect, we can use lens maker's formula. F liquid upon F air will be equal to refractive index of glass -1 into refractive index of liquid upon refractive index of glass minus refractive index of liquid. This will be 1.5 minus 1 into 9 by 8 divided by 1.5 minus 9 by 8. This will give us the answer 3 by 2. So focal length in liquid is 3 by 2 times focal length in air, which is given 20 centimeter. So focal length in liquid will be 30 centimeter. And as it is positive, it will behave as convex lens of focal length 30 centimeter. Next question. When a light of wavelength 4000 angstrom in vacuum travels through the same thickness in diamond and water separately, the difference in number of waves is 200. Find the thickness if refractive indices of diamond and water are 5 by 2 and 4 by 3 respectively. Here, the number of waves in water, let's say it is NW. It is given by optical path upon wavelength. The optical path travel is mu t, so 4 by 3 into t divided by lambda, where t is the thickness of diamond. The total number of waves in diamond are 5 by 2t upon lambda. It is given that n2 minus n1 is equals to 200. So put the values of n2 and n1 and solve for the value of t. We will get t is equals to 0.0685 millimeter. So third option is correct. Next question. A ray of light travels from an optically denser medium towards rarer medium. The critical angle for the two media is C. The maximum possible angle of deviation of the ray is. This is the conceptual question. The maximum possible angle of deviation is pi minus 2c. So second option is correct. Next question. The magnification produced by an astronomical telescope for normal adjustment is 10 and the length of the telescope is 1.1 meter. The magnification when the image is formed at least distant of distinct vision is. When image is formed at least distant of distinct vision, magnification is given by f naught into 1 upon d plus 1 upon fe. For that, we should know the value of FO and FE. The data is given that in normal adjustment, that means when image is created at infinity, magnification is 10. That is FO by FE is equals to 10 and length is 1.1. Solving this two, we will get F naught is equals to 1 meter and FE is equals to 0.1 meter. Put these values in magnification equation, we will get m is equals to 1 into 1 upon 0.25, that is least distance for distinct vision, plus 1 upon 0.1. Solve it and we will get m is equals to approximately 14. Next question. A thin prism of angle 6 degree made up of glass of refractive index 1.5 is combined with another prism made up of glass of refractive index 1.75 to produce dispersion without deviation. the angle of the second prism is. The condition for dispersion without deviation is A upon A dash is equal to n dash minus 1 upon n minus 1. So 6 upon A dash is equals to 1.75 minus 1 divided by 1.5 minus 1. Solve it and we will get A dash is equals to 4 degree. Next question. Wave theory cannot explain which phenomena? The wave theory cannot specify the Compton effect and photoelectric effect. So option C and D, third option is correct. Next one. A thin converging lens is made up of glass of refractive index 1.5. It acts like a concave lens of focal length 50 centimeter. When immersed in a liquid of refractive index 15/8, the focal length of converging lens in air is. Let us compare the focal length in two medium. Focal length in water divided by focal length in air is equal to refractive index of glass minus 1 divided by refractive index of glass upon refractive index of water minus 1. Put the values and simplify. We will get, but focal length in air is equal to 0.2 meter. Next question. ACB is a right-angled glass prism of refractive index 1.5. Angle A, B, and C are 60, 30, and 90 respectively. A thin layer of liquid is on the face AB. For a ray of light which is incident normally on AC to be totally reflected at AB, what is the refractive index of liquid on AB should be? It is the right angle triangle prism. Refractive index of prism is 1.5. Angle C is 90 degree. Angle A is 60 degree and angle B is 30 degree. A thin layer of liquid is on the face AB. Let's say refractive index of liquid is N. For a light ray which is incident normally on AC, light is incident normally on AC, to be totally reflected at AB, it should be totally reflected at AB. What should be the refractive index of liquid? From surface AB, light is totally refracted. That means light should be traveling from denser to rarer medium. So the refractive index of liquid must be less than 1.5. We have three options having refractive index lesser than 1.5. So we have to find the exact value. For that, the angle of incidence on surface AB must be less than or equal to the critical angle. First, let us find the angle of incidence. If this angle is 60, this angle is 90. Angle of incidence for surface AB will be 60 degree. So critical angle should be 60 or less than 60 degree. Less than or equal to 60 degree. So sine C should be less than or equal to sine 60 degree. Now we can find sine C is equals to n upon 1.5. So n upon 1.5 should be less than or equal to sine 60, that is root 3 by 2. So n should be less than or equal to root 3 into 3 by 2 to 2. Simplify this, we will get n should be less than or equal to 1.3. So maximum value should be 1.3. Let us see the next question. The phenomena used in optical fibers for transmission of light energy is total internal reflection. Next question. One of the refracting surface of prism of refractive index root 2 is silvered. The angle of prism is equal to the critical angle of a medium of refractive index 2. A ray of light incident on unsilvered surface passes through the prism and retraces its path after reflection at silvered face. Then the angle of incident on unsilvered surface is. Prism's refractive index is root 2. The angle of prism is equal to the critical angle of a medium of refractive index 2. Critical angle of a medium of refractive index 2 is 30 degree. So angle of prism here is 30 degree. A ray of light is incident on unsilvered face, passes through the prism and retrace its path after reflection at silvered face. Let's say this AC face is silvered. The light ray is incident, making some angle I. It is refracted and it has to incident normally on face AC to retrace its own path. So this angle is 90 degree. In this situation, the angle of refraction would be 30 degree. We want to find the angle of incidence on unsilvered face, that is I. So we can apply Snell's law at point P. Sine I is equals to root 2 sine 30 degree. So sine I is equals to root 2 sine 30 is 1 by 2, that is 1 by root 2. So I is equals to 45 degree. Next question. A ray of light is incident on the hypotenuse of right angle prism after traveling parallel to the base inside the prism. If mu is the refractive index of material of prism, the maximum value of base angle for which light is totally reflected from hypotenuse is. This is a right angle triangle. Light is incident on hypotenuse of right angle prism after traveling parallel to the base inside the prism. So it is incident in such a way. If mu is the refractive index of material of prism, the maximum value of base angle for which light is totally reflected from hypotenuse. We want to find this base angle. Let's say this is theta. To get totally reflected, this light has to be incident at critical angle. So this angle of incidence should be C. Sine C will be 1 by mu. This is the angle made with normal. So theta can be written as 90 minus C. So theta is equal to cos inverse 1 upon mu. So fourth option is correct. Let us see next question. The focal length of biconvex lens of refractive index 3 by 2 is 40 centimeter. Its focal length in meter when immersed in a liquid of refractive index 4 by 3 is. Here also we can compare the focal lengths using lens maker's formula. Lens maker formula is 1 by f is equals to n2 upon n1 minus 1 into 1 upon r1 minus 1 upon r2. So focal length in water upon focal length in air is equal to refractive index of glass minus 1 divided by refractive index of glass upon refractive index of water minus 1. Solve this and we will get the answer. 1.6 meter. Next question. A converging crown glass lens has focal length 20 centimeter for the violet rays. If focal length, its focal length for red rays will be given mu r and mu v. Here. 1 upon focal length is directly proportional to mu minus 1. So focal length for violet divided by focal length for red is equal to refractive index for red minus 1 divided by refractive index for violet minus 1. Put these values and find focal length of red rays. We will get FR is equals to 21.13 centimeter. Next question. A ray of light is incident on one of the refracting faces of an equilateral prism at an angle of incidence 48 degree. In the minimum deviation position, the angle of deviation produced by the prism is. Minimum deviation is given by 2i minus a. Here, angle of incidence is 48 degree, and as it is equilateral triangle, equilateral prism, angle of prism is 60 degree. Simplified and we will get minimum deviation as 36 degree. This is all for today. With this, our chapter is completed. Keep practicing and all the best for your future. Thank you.